In 5.2, we're going to find the graphs of derivatives and antiderivatives from graphs. Okay, that word antiderivatives, so right, if I'm going from f to f prime, I'm finding the derivative. So the antiderivative is working backwards. It's when you're given the derivative. We want to work backwards if you want to find the antiderivative. In other words, you want to find out what f is equal to. So we're going to take the graph of a function, and from the graph, we're going to try to sketch a graph of what the derivative looks like. And then we're going to take the graph of the derivative and work backwards to graph the antiderivative, or the graph of f. So let's start with this. Right, if I want to find the graph of a derivative, so if I have the function, I want to find its derivative. That could be going from f to f prime, or it could be going from f prime to f double prime. All we're going to do is pick points on the graph and estimate the slopes. And those will give me the positions on the derivative. So let's start right here. This graph starts at, we'll see, starts right there at, what's that, negative 3.5. If I were to estimate that slope right there, so think of the tangent line you go draw. I don't know exactly what it is, but it looks like about 2. So I'm going to go to negative 3.5. That's where the graph starts, and it's about 2. And notice how the slope is, or the graph is changing smoothly. So I'm going to come up here. The next point I'm going to do is right there at 2, and the slope is 0. So at negative 2, at negative 2, the slope is 0. And I want you to notice how the slope is changing smoothly. So we want this to change smoothly, like our graph is coming down like that. At 0, the slope is now a negative, and it looks like about a negative 1. So at 0, it's about a negative 1. At 2, looks like the slope is 0. And at 3.5, it looks like the slope is maybe 2. So 3.5. And notice how, again, the slope is changing gradually. So it's going to be a smooth curve when we draw this. That should be a pretty close approximation to what the derivative of f looks like. So again, you're just picking points along the graph and estimating the slope. The slope is the y values. The y values are the position of the derivative. Most of us do really well with those. Like we kind of know that already. Like estimate the slope, draw the graph. Where it gets a little bit trickier is when you're working backwards. So now I want to find the antiderivative. Again, an antiderivative is just going from the derivative backwards to the function. So to do that, you're going to make an f prime number line using the location or position of the points on the f prime graph. This is really important. Using the location of the position. If you want to put the y values of the points on the f prime. This does not involve the slope. So when you're doing the f prime number line and you have the graph of f prime, never look at the slopes. Now we also want to do a second derivative number line test so we can find concavity and points of inflection. When we do that, the second derivative is the slope of the first derivative. So when you do the double prime number line, now you've got to look at the slopes. So that's really important. We confuse those a lot. But once we have my f prime number line and f double prime number line, then we just use that information to try to draw a sketch of what it looks like. Sometimes they'll give you a starting point. So if they give you a starting point, that's where you're going to start at. If they don't, then you could basically take the same graph and you pick a starting point. So that graph could be shifted up and down vertically. I'll kind of show you what that looks like. Okay, so let's start here. So I'm given the graph of the derivative. So this is the slope of the function we're trying to draw. But the slope is the y values or the position. So what we mean by that is at negative 3.5, this f prime is equal to 0. That means the slope is 0. So let's come on here. Negative 3.5 is the starting point. It's also, the slope's also 0 there, so keep that in mind. Okay, and then at over here at 0, the slope is 0 again. Then over here at 3.5, it's equal to 0 again. Okay, and if you look at this, once I go past, it's 0 there. After I go past 3.5, the slope is gradually increasing. Those y values are gradually increasing all the way, and they're positive. They're positive all the way until I get to 0. So the slope has to be positive between negative 3.5 and 0. Once I get past 0, all my position or my y values are below. That means my slope has to be negative all the way across there. Okay, so what I have right there is, looks like a maximum, right? At 0 has to be positive slope, gets closer to 0, becomes negative, so a max when x is 0. Okay, let's try the f double prime number line. Can you do the f double prime number line? Now we're looking at the slopes of f prime. So let's look at the slopes. At negative 3.5, if we want to estimate that, I don't know. What does that look like? Maybe, let's actually, before we estimate that, let's do something else. Sorry. Let's actually find the possible points of inflection. So when I go to do that, I'm looking for when the slope equals 0. That's when the second derivative will equal 0, or when it's undefined, but it's never undefined on here. So right there, negative 2, it's equal to 0, the slope is, and at positive 2, the slope is equal to 0. Those are my possible points of inflection. Now just look to the left and right, decide when the slope is positive. So to the left, negative 2, the slope is positive. That means my second derivative has to be positive. To the right of 2, the slope is positive. That means my second derivative has to be positive. Between negative 2 and 2, the slope is negative, which means my second derivative has to be negative. Okay, so now I've got this f prime and f double prime number line. We're going to try to draw a sketch of what this looks like. So let's start by putting a point. This one gives us a starting point at 0, 1. And that's also where we have a maximum. So the slope is positive to the right, so I know, and negative to the left. Between negative 2 and 2, it's also concave down. So I don't know exactly what it's like. I'm going to draw this middle part. I know it's something like this. Right? I've got to have a max right there, and it's got to be concave down. And it's concave down until I get to negative 2, and then it changes to concave up. So I'm going to make it concave down all the way to negative 2. And at negative 2, it changes, and now it has to be concave up. It doesn't go past 3.5. So 3.5 is where it's going to end. So something like that. Over on this other side, it's concave, it's decreasing and concave down until I get to 2. Once I get to 2, it changes to decreasing but concave up. So my graph is going to look something like that. So let's double check it. I got a max at 0. I got a concave down between negative 2 and 2. Concave up from negative 2 to 3.5 and from 2 to 3.5. So my graph ends up looking something similar to that. Now, something to be aware of, if it had not have given me a starting point of 0, 1, then I could pick the starting point wherever I wanted. And so what you can do, if there's not a starting point, is basically that graph, you could start anywhere you wanted. You could start down here and draw it. You could start up here and draw it. What you have to make sure of is at 0, there's a max. At negative 2, between negative 2 and 2, it's concave down, and on the outside pieces, it's concave up. So that's what it's talking about. If there's not a starting point, you're free to shift it vertically. It doesn't really matter where the starting point is, as long as you have the max and min at the right x values and the concavity is correct over the intervals. Let's try another one. So this one says, use a graph of f prime shown to draw the sketch of f double prime and a possible graph of f. So let's start by let's take f prime and let's draw the graph of f double prime. So remember, when we're doing that, we're just looking at the slopes. So now I'm taking a graph and I'm going to its derivatives. Just check out the slopes. So let's pick some numbers and plug in some slopes. At negative 4, we don't have to estimate the slope. We know what the slope is, right? The slope of that line is 1. So at negative 4, the slope is 1. At negative 3, the slope is 1. At negative 2, the slope is still 1. And it's going to be 1 all the way until I get to 0. Now at 0, the slope is not 1. The slope is undefined. So I'm just going to put an open dot there. So the left side of the graph is going to look like that. The slope is always 1. Okay, let's pick some values on the right side and estimate the slope. If I come right here, just past 0, right in there, that slope is pretty close to 0. So I think it doesn't include 0 because there's a sharp turn there, but it's going to be pretty close to 0 right there. Let's pick another point like right here. When x is 1, if I were estimating that, that looks pretty close to 2. And then it's getting even steeper up here, right? So I don't know. It could be linear over there. It could be like maybe increasing at a curve like that. We can't really tell which one. Either one is fine. But main thing we have to do is that it's getting steeper. As it goes to the right, the slope is getting steeper, it's increasing. So you can either make that linear or not. Those to me are the easier ones. When you're trying to graph the derivative, all you do is just pick points along your graph and estimate the slope. Those are the y values of your derivative. Okay, now we're going to go back though, and now this is where it gets a little bit trickier, is we're going to take the graph of f prime and try to draw a sketch of what the graph of f looks like. So use your number lines always. Draw your number lines every time on these. So start with f prime. For f prime, I look at the f prime number line. I want to look at when my derivative is equal to 0 or undefined. Well, that graph is always defined, but it is equal to 0. I mean, you're looking at the position. It's equal to 0 right there when x is -2. To the left of -2, all of my values, my position is negative. To the right of -2, my position is always positive. So I've got, that means at -2, I have a relative minimum. Okay, let's do the second derivative. Now we could kind of cheat because I have the graph of the second derivative. You can look at the y values of our graph over here, or I can look at the slope of our graph over here. Now what I'm focused on is those possible points of inflections. So with the first derivative, you're looking for the critical numbers, which is when it's equal to 0 or undefined. For the second derivative, you're looking for those possible points of inflection. That's when the second derivative is equal to 0 or undefined. So what I'm doing is I'm looking at the graph of f prime and saying, when is the slope of that graph 0 or undefined? So right there is the only place. And at that point, the slope is undefined. So my only possible, when x is 0, I have a possible point of inflection. Okay, just look at the slope to the left and right of that. To the left of it, the slope is positive. To the right of it, the slope is positive. So there is not a point of inflection there. And this graph is always going to be concave up. Now there is something that's happening here. If you look at the slope over here, it's always positive, but it's staying the same. Once you get past here, the slope is getting bigger, it's getting steeper. So we'll see if we can kind of incorporate that into our graph. Okay, notice on this one does not give us it doesn't give us a starting point. And so we can pick our starting point. What I'm going to use for my starting point is I know there's a relative min at -2. So I'm going to come over to -2 and pick a point, it doesn't matter where, and put a relative min. So now that has to be a relative min. The graph's always concave up. The slope has to be negative to the left and positive to the right. So something like that. And it keeps coming up until you get to 0. Now one thing at 0 you have to be careful with is something changes, like the slope is getting bigger, right? The slope is getting bigger. But at this point, it actually starts getting even steeper faster. The way you have to be careful with is there can't be a sharp turn at 0. So it can keep going like this, and then maybe it gets even steeper up there. But there can't really be a sharp turn, because if there were a sharp turn, then my first derivative would be undefined at 0. Well, there is a point at 0, right? The slope is 2, so the derivative is defined. So it does something kind of funny there. Those are hard to draw. We're not looking for perfection. Make sure I have my relative min. Make sure it's always concave up. If you want to draw where it's getting just a little bit steeper after that, that's fine, but it has to be a smooth curve right there. It cannot be a sharp turn when those change. So these can be a little bit tricky. The key to drawing the antiderivative is these number lines, always. You cannot, it's really, I guess you could, but it's really difficult to draw those without first doing your f prime number line and your f double prime number line. Remember when you go to do those, f prime, you're looking at the position of the derivative. You're looking at the y values. Is it positive, negative? When is it equal to 0? Those will be your critical numbers. When you go to do your f double prime number line, you're looking at the slope of the derivative. So when is the slope equal to 0, or when is the slope undefined? And those will be your possible points of inflection. These are a little bit tricky. They're not, the nice thing is you don't have like super long problems where you're doing these, all this algebra. The hard part is sometimes it's a little hard for us to wrap our minds around them. So focus on the procedures. If you're going from f to f prime, pick points and estimate the slope. If you're finding the antiderivative, draw the number lines. Draw the number lines every time. All right. Good luck.